Transformation from 2024 final examination paper 4. First question, describe fully the single transformation that maps triangle A onto triangle B. Triangle A onto B. Now when you are dealing with this stuff, you just check two things and then sometimes three. The first thing to check is the size. What happened to the size of the image and the object? In this case, it's the same. What happened to the orientation? Orientation and facing, in our case, they are just facing each other. And once that happens, you know it's definitely a reflection. So just come and write the reflection. This is a reflection along a line. Let's check the line of reflection. First things first, let's calculate this distance from here. It's 1, 2, 3, and 4 units. Half of 4 is 2. So going to 2 units, it's going to be 1, 2, which means it's definitely this line here. That's the line of reflection, and that's the line x equals to -1. Next question, A onto C. Let's compare size. Size is the same. Orientation over here. Orientation. They are still facing the same direction and they've just swayed position. Position changed. And you definitely know that's the translation. So let's just go and write. This is translation by the vector. What's the translation vector? Let's identify corresponding points. Now this is the point is corresponding to this one here. And then you can tell that this is definitely how many units? 1, 2, 3, 4, 5, 6 units. So the left 6 units left. And then let's check it downwards. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units down. Units down. Let's write that as a vector. Left it's negative, down it's negatives. Through the vector -6, -8, but just write it as a vector, not as a coordinates like I did. Transformation matrices. Wow. This is might look somehow difficult for most of you, but let me try to simplify this thing. They are telling you this one that for this one they are telling you that triangle A is transformed onto D using this matrix, which means each coordinate, each vertex of the triangle is being multiplied by that matrix to find the corresponding image. Let's try to find the corresponding images for this one now. First things first, let's first go and identify the coordinates of the vertices of triangle A. Vertices of triangle A. Okay, I'm gonna do this first. Let me say this is point A. This is B. And this is C. Nice one. Nice one. So for A, the coordinate there is 2, 7. Next coordinate B. What is the coordinate of B? It's 1, 5. Next, C. What's the coordinate of C? 4, comma what? 1, 5. Nice one. Let's take this one into our working space. Here. Now that's our working space there. Are these the coordinates I'm dealing with? I'm not sure. Let me check. Well, they are actually. And then is this the matrix I'm dealing with? Let me check. 0, 1, negative 1, 0. It's actually the matrix I'm dealing with. So what you are going to do, you are going to take each point and multiply it by the matrix. Make sure you are pre-multiplying each point by the matrix. So you convert this thing to look something like a vector, just like this. Okay, I'm going to do that just like this one here. Just make it look like this vector here. So this is 2, that's the x, and that's 2 here on top, and then below is the 7, which represents the y. What's the solution for that? Try to write the solution. So the solution is definitely going to be 0 times 2 is 0, plus 1 times 7 is 7. And then below you are having your negative 2 times 2, giving you negative 2, plus your 0 times 7, that's 0. And this is going to give you nothing but the following. Now this is what this is giving as 0 plus 7, that's 7. And then your negative 2 plus 2, that's negative 2. Now in the interest of time, you can actually combine all three coordinates as column vectors, just like this. Let's see, just like this. So you are just first going to write your matrix here. Let's first write the matrix. So that was 0 and 1. And then the negative 1 and 0, like that. That's the matrix that we were given. Alright, now that you have the matrix there, multiply this by the other matrix. So the first point there, we've already used the 2 comma 7, which is 2, 7 as a column vector. Now we need 1 comma 5, which is 1, 5, 1, 5 as a column vector. The other one is 4, 5 as a column vector. Sorry, something like that. Now what's going to be the solution for multiplying these two matrices? This is going to be equals to your 0 times 1 with 0, plus your 1 times 5, that's 5. Next, it's going to be your 0 times 4, plus 0, plus your 1 times 5, that's 5. And then on the bottom row, you are going to have your negative 1 times 1, negative 1 times 1, that's negative 1. And then plus 0 times 5, that's 0. And then the other one is negative 1 times 4, giving us negative 4 plus 0 times 5, which is 0. We can do this one, negative 1 times 4, that's negative 4. And then 0 times 5, that's 8 plus 0, like that. Now let's try to write the answer here. And then your 0 plus 5 is 5, and then your 5 plus 0, that's 5. And then bottom column is going to be a negative 1, negative 4. So the images of 1, 5, it's going to be your this one here. So it's this one here. That's the image of 1 comma 5. It's 5, negative 1, and then the image of the other one, which is, maybe let's start with the image of 1, 5. It's 5, negative 1. So let's write that. it's going to be, sorry, it was B 1 5, and we are saying its image, which is B image, is going to be your 5 comma negative 1, 5 comma negative 1, and then C, which is the other coordinate, 4 comma 5. The image for that, it's going to be your 5 negative 4. Now let's try to combine all this. Now let's go and plot this side here. Since it has a lot of negatives on the y, it means that it's actually in the fourth quadrant. This is in the fourth quadrant. Let's go into this one to plot in the fourth quadrant. So this is our point. The first point we found is actually a negative. It's 7 comma negative 2. This is the point here. And then the other one is 5 negative 1. This is the point here. And then the other one is 5 negative 4. 5 negative 4. It's actually here. Let me draw that. It's something like this. Nice one. That's the image. And then we told us to call this one image D. Just write D here. Another D. And then you are required to describe this transformation A to D. Let's check the two things that we always check: size. The size is the same, and then the orientation. The shape has been flipped around or simply rotated. So definitely this is going to give you what? A rotation. Rotation, let's find the angle of rotation. Let's find the angle of. Now for simplicity, I've decided to draw this figure on GeoGebra. Let's check it. Now, to find the center of rotation, we've always mentioned that you need to identify two corresponding points and then draw a line segment joining the two corresponding points. For example, this point here corresponds to that. And then after that, draw a perpendicular bisector on that. So drawing a perpendicular bisector, just draw a circle passing through each point with the same radius. Make sure the radius is more than the distance, the half of the distance between the two lines. So the first circle, I'm going to use radius 6, and then C, and then draw another circle of radius 6 there. And then where these two circles are meeting, I'm drawing a line there. Draw a line segment. Actually, that's the perpendicular bisector. Let me color it red. Let me color this one red. Identify another two pairs of corresponding points. That's the B and F. B and F. We draw. Let's draw the line segment between B and F. B to F. And then draw two circles with the radius more than half of the distance between those 2 points. These 2 points from -4 to, well, that distance is about 9. So I can also do the 6 here, or 5 if I like. Let me draw the cyclist, this one with the radius 5, and another one with the radius 5, and they are meeting there. As they are meeting there, let me join the line segment connecting those two. And they are meeting at 0, 0. So that is telling us that the center of rotation is at 0, 0. Let's go back to our working diagram. Here we are. Now, corresponding points, it's this one that I've labeled. Then just draw a line from the center of rotation to the image like that. And then the corresponding point to that thing that I just drew, it's that one I labeled C. Let me draw another line too. So we want to define the transformation that links A to D. A to D. So from A to D, that's the direction. As simple as that, good people. And that thing, by me looking, it's 90 degrees. So that's 90 degrees clockwise. Don't go for this one. Don't go for this one. That's too long. Always prefer the short distance, and say it's negative. It's 270 degrees anti-clockwise. Now that's too big. Go for the short distance always. So now let's go and explain this one. We already say this is a rotation. About the origin. By 90 degrees clockwise. Next question, you are required to find matrix B, which represents an enlargement with a scale vector -2 about 0, 0. So that's a pretty simple one. For enlargement, the matrix, it's this one. It's going to be a matrix with 0, 0 everywhere, but it's going to have the scale vector on the main diagonal. So we are saying it's going to have your scale vector. Let me call the scale vector V, 0 and 0. For the transformation matrix of enlargement across the center 0, 0, it's always going to be the transformation. It's always going to be this transformation where your V represent the scale vector, and then you just replace the V with the given scale vector. In our case, we were given -2 as the scale vector. So basically that's the transformation matrix. Let's just write